Okay, for this video lecture, there are two questions I'm going to be answering. The first is let H and K be subspaces of vector space V, and I'm supposed to show that the intersection of H and K is also a subspace of V. So in this example, H and K are both planes inside the vector space V, and we know that the intersection of two planes are just going to be a straight line. We know that. So knowing that the intersection is a straight line, we can move on to checking to see if the line is also a subspace. So first, there are three checks we need to make. First is that the zero vector of V is in the intersection of H and K. And so I think this one's easier to just visualize. So if you have two of anything, a line or plane of anything, if they both contain one point, they both contain the same point, then that point has to be on the intersection. It has to be right there. So that one's pretty easy. So we know if H and K are both subspaces, they both have the zero vector, and so we know that their intersection has the zero vector. Okay. The next check we have to make is that the intersection of H and K is closed under addition. So for this, I think it's easier to think about it if it was on the x1 axis. So right here we have two vectors on the x1 axis, and if you add them up, you get another vector also on the x1 axis, which is also on the intersection. And that would work for anything. You could use any numbers, any vectors, they would all add up, be on the same line. And that's kind of just a property of lines. Okay, and then the third, we have to check that H and K, or that the intersection of H and K is closed under the multiplication of scalars. So this one's pretty easy too. So if we have the vector on the x1 axis and we multiply it by any scalar, we also just get a vector on the x1 axis that has a different magnitude. So all three of those, they all check off. We know that H and K is a subspace of V. Okay, the second question is give an example in R2 to show that the union of two subspaces is not, in general, a subspace. So first, we have to know what a union is because it's not as trivial as an intersection. So a union is being used to indicate that vectors can be taken from both subspaces, but when operated on, they have to be in one or the other subspace. So here we have two subspaces. W1 is the x1 axis, W2 is the x2 axis, and then we'll have two vectors, u and v. U is on the x1 axis, so it's in subspace W1, and v is on the x2 axis, so it's in the subspace W2. So we know that the addition of u and v will be in the union of W1 and W2. So if you take those two vectors and add them together, you would get 1, 1, which you can see is not on the x1 or the x2 axis, meaning that it is not a subspace